It's also another video. Welcome back. My name is Mwiza Chirwa. I'll take you through lesson part 3 on the same topic, that is hydrocarbons. This is a topic from chemistry book 2. So the success criteria that we're supposed to achieve by the end of our presentation is to describe the chemical properties of alkanes and describe the sources of alkanes. Remember, in part 2 we looked at the physical properties of alkanes as well as the preparation of alkanes. Now we'll focus on the chemical properties of alkanes, as well as we should be able to describe some of the sources of alkanes. So we'll start by looking at the chemical properties of alkanes. So in the first part, should be the first part of our topic, we said alkanes are less reactive, but they can still react depending on the conditions which are there, because they form strong carbon to carbon as well as carbon to hydrogen covalent bonds. So here we are saying that in general alkanes are less reactive compared with the other hydrocarbons, which are alkenes, because they form strong carbon to carbon as well as carbon to hydrogen covalent bond. In short, they are saturated. They have single bonds throughout their molecule. While alkenes, they have double bonds, which makes them to be more reactive. During chemical reaction, the double bond breaks and allow other atoms as well as groups to join the molecule. So since they are less reactive, they can only react with reactive substances. So the chemical properties of alkanes are relatively simple compared to other hydrocarbons due to the lack of the functional group. Remember, we said an alkane do not have a functional group. Here are some of the chemical properties of alkanes. So in this lesson, we'll only discuss two chemical properties of alkanes. So we have the first one as combustion reaction. They undergo combustion reaction, and the other one is that alkanes undergo substitution reaction. So we are going to look into details about all these chemical properties and what happens during each of them. So when we talk about combustion reaction, here we have said alkanes undergo combustion reaction. So what is a combustion reaction? So we can define a combustion reaction as follows. It refers to burning of substance in oxygen. So combustion reaction, it is a reaction in which a substance burns in oxygen. So there are two types of combustion reaction. These are complete combustion and incomplete combustion. So let us look into details about the differences between these types of combustion and what makes the substance to undergo either complete or incomplete combustion. So to begin with, a complete combustion. What is a complete combustion? The word complete, what does it mean? It means something which is successful. So it is a type of reaction in which substance burn in sufficient or enough oxygen and produce carbon dioxide and water. So the main products that we can find in complete combustion is carbon dioxide and water. Alkanes undergo complete combustion when there is always adequate or enough or sufficient supply of oxygen, and when you are using smaller chain alkane. Smaller chain alkane simply mean the alkane which has a few number of carbon and hydrogen atoms. Example of complete combustion: methane reacting with oxygen. Remember, methane is simple, the first alkane, reacting with oxygen, enough oxygen to produce carbon dioxide and water. So sometimes you'll be asked to write the chemical formulas of complete combustion. one thing that you need to keep in mind is that there will always be carbon dioxide being produced and water. These are the major and the main products that are going to be produced when a substance undergoes complete combustion. So this is a word equation which can be also illustrated by the chemical equation. Here we have methane, which is CH4. We have oxygen here, which is O2. We have carbon dioxide, which is CO2, and we have water, which is H2O. The equations illustrate the complete combustion. So what else do we expect in complete combustion? So a complete combustion produces a lot of heat. So the reaction is exothermic reaction. It also produces less soot and sometimes no soot at all. The reaction produces a blue flame. So these are some of the characteristics of complete combustion. First of all, we have said in complete combustion, we have products such as carbon dioxide and water. In complete combustion, there is a lot of heat which is going to be produced. In complete combustion, there will be less soot which is going to be produced, and the color of flame is blue. So these are the characteristics of complete combustion. When a substance burns in enough oxygen, we expect to have these characteristics that we have discussed. The second one is incomplete combustion. So what is incomplete combustion? It is a type of reaction in which substance burn in insufficient oxygen to produce carbon monoxide or carbon and water. So we expect at least two types of products. It can burn in insufficient oxygen to produce carbon monoxide and water, or to produce carbon monoxide, carbon and water. So alkanes undergo incomplete combustion when there is insufficient amount or supply of oxygen, as well as when the molecular size is large or increases. So here we have some examples of incomplete combustion. So I've said we have a general equation, alkane plus oxygen, carbon monoxide and water. And here we said that the products can vary. So sometimes this one, for example, here we are using octane. It's reacting with limited amount of oxygen, and we said it can also go through incomplete combustion because of the carbon chain. So if you can see, octane is a long chain alkane with 8 carbon atoms and 18 hydrogen atoms. So this one can undergo incomplete combustion and produce carbon and water, as you can see on the product. As well as it can also undergo the same incomplete combustion to produce carbon monoxide, carbon and water. So these are some of the products that can be formed when the substance undergo incomplete combustion. Now we'll look at the characteristics of incomplete combustion. So the first characteristic that we can draw from what we have discussed is that there will be presence of limited amount of oxygen, as well as the carbon chain is large. So we also have other characteristics. The reaction produce a yellow flame color. The reaction produce a yellow flame color, and there will be more soot which is going to be produced. There will be more soot produced, and there will be less heat which is going to be produced. So these are the characteristics of incomplete combustion. First of all, there is insufficient oxygen, as well as the carbon chain of an alkane used is long, and it produces yellow flame, and it produces more soot, as well as produces less heat. The second chemical property is that an alkane undergoes substitution reaction. An alkane or alkanes undergoes substitution reaction. So what is substitution reaction? It is a type of reaction in which one hydrogen atom in an alkane is substituted by another atom. It is a type of reaction in which one hydrogen atom of an alkane is substituted by another atom. So, example, reaction between chlorine and methane. The reaction between chlorine and methane. Alkane do not react with halogen in dark. Why is it like that? Alkane do not react with halogen in dark. Here we simply mean that one of the conditions that we need for an alkane to react with a halogen is presence of heat. Remember, we said they form strong covalent bond between carbon to carbon and carbon to hydrogen. So without a catalyst to initiate the reaction, they will not react. That is what it means by this statement. Enough energy is needed to break the bonds in the reactant phase before the reaction can occur. The energy comes from the sun. So here we have steps of some of the process that occurs when an alkane undergoes substitution reaction. First, we'll look at the reaction between an alkane and a halogen known as chlorine. So the reaction can occur in steps depending on the availability of chlorine. So the first step, methane react with chlorine. Here we have UV light. UV light is a catalyst which catalyzes the reaction. Chloromethane is being produced and hydrogen chloride. So this one can be illustrated in the chemical equation as well as the structural equation, which is here. So we have chlorine reacting with methane to produce chloroethane as well as hydrogen chloride. Now, if you check here, we had 4 hydrogen atoms, but in this side in chloromethane, we have 3 hydrogen and a chlorine molecule. Simply means that the chlorine atom has substituted the hydrogen atom to form chloromethane. And the hydrogen which has been removed here and the remaining chlorine atoms, they join together again to form hydrochloric acid or hydrogen chloride. So this is just the structure formula of what is being illustrated in the word as well as chemical equation. So in summary, in the reaction from the previous slide, the reaction chlorine atom reacts with methane and replaces a hydrogen atom in the methane molecule. In presence of excess chlorine, now we need to understand here. In presence of excess chlorine, further substitution of the remaining hydrogen can occur. It means if you have enough chlorine, all the hydrogen from an alkane can be replaced with chlorine. And finally, all hydrogen atoms are substituted by chlorine atoms to form a tetrachloromethane. So in step 2, if we have enough chlorine, what do we expect? Since in the first part, chloromethane was being produced, now chloromethane is going to react with the chlorine and another hydrogen atom is going to be replaced by chlorine atom to form here dichloromethane. Di means here now you have what? You have 2 chlorine atoms which are attached to a methane molecule. And here the other product will be HCl. So here we have the chemical structures of the reactants, which are illustrated from the word as well as the chemical equation. Step 3, since in step 2 we're going to produce dichloroethane in presence of enough amount of chlorine, dichloromethane can also react to produce trichloromethane, where one hydrogen, one hydrogen from methane is replaced by chlorine to form trichloromethane. So this is the structures of the reactant and the product from the equation illustrated by both word and chemical equations. We have step 4, trichloromethane and chlorine, which is produced in trichloromethane is produced in step number 3, react with chlorine to produce tetra. Tetra means 4. So it means in the product we are going to have 4 chlorine atoms as illustrated in the structure formula. So care must always be taken with the equation. We always replace one hydrogen per time, but at the end we find that all hydrogen have been replaced. So in similar way, bromine can be substituted again to form tetrabromomethane. So if we are to use bromine, this is the first step. Methane react with bromine, the UV light, bromomethane, hydrogen bromide. So here we have methane, we have bromine, we have UV light, which act as a catalyst to produce bromomethane. Bromomethane can react with bromine again to form dibromomethane, as illustrated here by the equations. Dibromomethane plus bromine, UV light, it produces tribromomethane and hydrogen bromide. So this one is illustrated by both chemical equation and the structure of the reactant and products. Now step number 4, tribromomethane can also react with bromine under UV light to produce tetrabromomethane, similar to what happens with chlorine. We can also have the same things as well. Now, apart from the chemical properties, so far we have looked at the 2 chemical properties in which alkanes can undergo. We have said it undergo combustion reaction where it burns in oxygen to produce carbon dioxide and water, or it can undergo incomplete combustion where it produces carbon monoxide, carbon, as well as water. Now we'll focus on the sources of alkanes. So some of the sources of alkanes include the following. We have natural gas. The main component of natural gas is methane, which is an alkane. So this natural gas becomes a source of an alkane. So the other gases which are found in natural gases include nitrogen and helium. Then we can also, another source of alkane is crude oil. This is the main source of alkanes. Remember, crude oil is made from fossil fuels, that is plants as well as animals. So crude oil can be separated into its component by fractional distillation and collected separately based on their boiling points. Components of crude oil. Remember, we said crude oil can be made from plants and animal remains as well as fossil. So in those crude oil, we can find an alkane, and some of the components of alkanes which are found in crude oil, we have gasoline, diesel, kerosene, petrol. This also comprises on the crude oil. So during separation, we can get each alkane differently. Another source is through cracking of large alkanes. So what is cracking? Cracking means breaking of large hydrocarbon molecule into smaller, lighter, and more useful bits. This can be achieved by using high temperature, pressure, and a catalyst. One of the catalysts that we can use is aluminium. This process is also known as cracking and is commonly used in petrochemical industries. So here we have dodecane, have a catalyst to heat, hexane, butene, ethene, and hydrogen gas. So sometimes be very careful with the equations. So here we have dodecane, we have hexane, butene, ethene, and hydrogen gas. So this is the chemical formula of what we have explained so far in the process where cracking occurs. So far we have covered our objectives that we wanted to achieve. We have looked so far on the chemical properties of alkanes. We have said alkanes are less reactive. They are less reactive because they form strong carbon to carbon, carbon to hydrogen covalent bonds. And for them to react, it means they are supposed to be subjected to heat. So the chemical properties in which alkanes can undergo, we have said they undergo combustion reaction as well as a substitution reaction. On combustion reaction, we have looked at the definition of combustion reaction, where we have said it is a type of reaction in which a substance burns in oxygen. We have two types of combustion. We have said we have complete and incomplete. So alkanes undergo combustion. If it is complete combustion, we expect the following products, that is carbon dioxide and water. But if it is incomplete combustion, we can either find carbon monoxide and water, or carbon monoxide, carbon and water. We have looked again on the substitution reaction, where we have defined substitution reaction as a type of reaction in which an alkane, a hydrogen atom from an alkane is substituted by a more reactive atom. So in substitution reaction, we said an alkane may react with halogens to form a haloalkane. For example, we have used two reactions where methane is reacting with the chlorine to produce chloromethane or bromomethane, depending on the halogen used. So that one, the reaction of substitution reaction can continue up to until all the hydrogen atoms have been replaced, as well as also it depends with the amount of oxygen, amount of chlorine, I mean, which is present. If you have enough chlorine, it means it can be replaced throughout. So that is just a summary of what we have covered so far in this video. Now, before we end everything, we have a buzz session, a quick exercise, just to check up on our understanding based on the concept that have been shared in this video. So the first question is, write the chemical equation for the combustion of methane. Write the chemical equation for the combustion of methane. The second question, state three differences between complete and incomplete combustion. State the difference between three differences between complete and incomplete combustion. Question number 3, state condition necessary for substitution reaction of ethane with bromine. Some of the conditions that are required for the reaction of ethane with bromine. Write an equation to show how hydrogen atoms are substituted when ethane reacts with bromine. Give the names of two alkanes that can undergo incomplete combustion. Classify the following reactions as complete or incomplete combustion. So we have this one A and this one Roman numeral 2. So for more information, you can visit us or you can catch up with us using the WhatsApp number, or you can also visit us through our website, that is Xulendo.org. And for further information, if you'd like to search more, these are the resources that I have used. You can check for more information in the following references: Excel and Succeed Chemistry Book 2, Achievers Chemistry Book 2, and Target Chemistry Book 2. And for the photos that we have used, here is the link which you can click to check on the photos that we have used in this presentation. This marks the end of our presentation on hydrocarbons part 3. Expect another lesson in part 4.